All right, this is chapter 6. We're continuing on. This is part 3, returning a value from a function. So we've already discussed this a little bit. We've already been doing it a little bit with our int main, but we're going to talk about doing it with other functions. So when returning a value from a function can return a value back to the statement that called the function. You've already seen the POW function, which returns a value. So here, we're actually making use of a function that was already available to us. We're passing in parameters, and we're getting a return back. In a value returning function, the return statement can be used to return a value from the function to the point of call. All that's saying is, where this function is being called, we're going to return that value back to that point. To do this, we got to make sure that our function says and declares what kind of return type we will have, which in this case is going to be an int. And in this case, you can see we're actually adding two numbers here, storing it into the double result and returning result. Now remember, result can be shortened to int. It's not the smartest thing to do, again, because double could be smaller than int, but in this case it works out well because our incoming variables are ints as well. So functions can return the values of expressions such as n1 plus n2. We've seen this all over the place. We've been doing it for a while. Nothing too exciting here. In fact, we have a little function here that's going to make use of exactly what we've done over in our other compiler windows, where we've added numbers together. This one, or that, excuse me, the one we were just looking at also outputs it. This one takes and just adds the numbers together and then returns it. Very similar to what we're talking about here. To follow along with what's going on here, we got that sum, the value 1, value 2, and as we know, the values are being passed in to the incoming parameters. Even if value 1 and value 2 themselves are going to be variables, as long as they're the right type of variable, they can pass in. Here's another example, and this is where we've got pi times a function which is called square radius. This square is calling out to another function where it's taking the number and timesing it by itself and then returning that as a double. The prototype of the definition must indicate the data type of the return value, not void. Because remember, void means there's no data being returned. Calling a function should use return value. It assigns it to a variable, sends it to a cout, and use it in an expression. Well, this is just, to be honest with you, this is just an example of a calling function should use return value. So what they're saying is they assign it to a variable, they send it to cout, and then use it in an expression. So far we've been passing back most often either ints or doubles. This time we're going to return back a Boolean value. So functions can return back true or false. Declare return type in the function prototype in the heading as bool, which makes sense because, again, as we've been talking about, when we declare the function, let's find one of those here, we would have to change this to bool, B-O-O-L, to indicate that a Boolean is going to come back. Function body must contain return statement that returns true or false. The calling function can use this return value in a rational expression. So we see this a lot, and that is And remember, I was telling you about in a previous video, a lot of organizations, when you're asking for a state or something along those lines, especially if it's returning back a Boolean, the word is a great precursor to the function name. It helps to indicate that this is going to be something that returns a value, oftentimes a Boolean. So this is saying, hey, if is even, and it's passing in this val. So we're saying in this function, enter an integer, and I will tell you if it's even or odd. And then we take in a val. Then we say if, and we're going to kick this over to a function, which we can see in our function prototype up here. Our function prototype, that this is expecting an int. So as long as val is an int, and it is, then we can pass it into is even. Now, you can put the double equal sign and say true here, but you don't have to, because as long as this statement equates out to true, remember, an expression is just looking for that alone. It just wants to see a true or false. So if the function passes back a true or false for you, you don't have to say equal sign, true. And here is that function, is even. It's going to take in the number. It's setting up a return value that we're going to use later called status. And then it's going to do the modulus 2 equals 0. If that's the case, then we know the number is even because there's no remainder, because you're dividing it by 2 and there's no remainder. Otherwise, the status is false because it's an odd number, and then it returns that status. Now let's talk a little bit about local and global variables. Variables defined inside a function are local to that function. They are hidden from statements in other functions which normally cannot access them. Now you're going to probably go, oh, Professor Waits, what is this all about? I feel like we've talked about this. We just didn't give a name to it. In fact, this is known as scope. We're talking about scope here. So anytime you have something like this int x1 inside this bracket, only this main function knows about it because it's in this function. This other function doesn't know about it. So that's known as a local variable. They're hidden from the statements in other functions which normally cannot access them. Because the variables defined in a function are hidden, other functions may have separate, distinct variables with the same name. And that happens all the time, especially if you're using common variable names. Like oftentimes I use the variable name return val as my variable that I'm going to return back at the end of the function. So that's common. Two functions can have that as long as they're local variables. So here we have in this, we're talking local variables. It's going to be to main, int num is a local variable. Then we're calling out to this other function. And as you can see, int num is being used here too, because again, they're both local variables to the function itself. And so you can do that. The local variable's lifetime. A function's local variables exist only while the function is executing. This is known as the lifetime of a local variable. It's also the scope of the variable, or scope of the function. When the function begins, its local variables and its parameter variables are created in memory, and when the function ends, the local variables and parameter variables are destroyed. That's why I think of these brackets as, okay, here we're creating the variables and we've created them on inside this bracket, but once we leave this bracket, they're going to be destroyed. So this means that any value stored in local variable is lost between calls to the function in which the variable is declared. Now this is a little bit of a little crazy one. It doesn't really explain it well. And what they're saying though is, see how I have this return x in this function? Every time I call the add numbers, return x is created it returns a variable, but then as soon as we hit this in bracket, it's destroyed. So every time I call add number, this return X is being created and destroyed for each time. Not the fact that it's being created or destroyed over here. It's within this function itself. The calling function, I should say. Now, global variables and global constants. A global variable is any variable defined outside all of the functions in a program. The scope of a global variable is the portion of the program from the variable definition to the end. So we're going to see that here in a moment, where global variables have a much broader scope. They don't really have to worry about as much brackets, but I'll show you that here in a moment. So this means that a global variable can be accessed by all functions that are defined after the global variable is defined. You should avoid making global variables because they make programs difficult to debug. This is something that you'll get in the habit of doing as a developer. Oftentimes we like to make these global variables because they're just easy to use, and you can pass data back and forth. You're not actually passing, but you can use these variables among the different functions. And so we love to create these global variables, but it does make things very difficult to debug. And also, it makes it to where your program can really start making some mistakes overwriting data. So we try to avoid using global variables, believe it or not. Global constants, a little bit different. These are constants, which we've already talked about, often uppercase, all uppercase, but they are just oftentimes literals that are being put into a variable. A good example is pi. If your program needs to use pi, well, pi is 3.14. We know that. If you want to get more accurate, pi is 22 divided by 7. And so you could set that up as a constant that's at a global level, so all of your functions can make use of it. So how do we do this? Well, let's talk about the global constants, because they tend to be the item that we use the most. And as you can see before our function prototypes, we set up these global constants. They are under the namespace, but they are above our function prototypes. And again, we have these const, which stands for that it's a constant variable. It's of type double. We have capital letters because we want to let everyone, when we use it in our code, automatically see that it's a constant. And it stands for 22.55. Which makes sense in this program because obviously the pay rate's always going to be $22.55. It's never going to go up. And same thing with base hours. It's always going to be 40. And the OT multiplier, 1.5. These are all constant variables that we want to assign to a word. And oftentimes these words really do make sense of what they are. So it's easier to see them in the code later. So here's some snippets of code, and we're saying, hey, if the person, the hours worked is greater than the base hours, and that's a constant, then we can take base hours times pay rate. Else, you want to take the hours worked times pay rate. And that's because part of the requirements, if you don't remember this, part of the requirements for this function was if the employee works 0 to 40 hours, they're always going to get paid 40 hours. So even if they only work 35, they're going to get the base hours, which is 40, times the pay rate. But this is now using those global variables. In fact, sorry, let me rephrase that. That's using global constants, which are global variables as well, but they're a little bit more precise of a type of variable. So when we're initializing local and global variables are not automatically initialized. They must be initialized by programmer. The global variables, not constants, are automatically initialized to 0, numeric or null character when the variable is defined. So what does that mean? Well, local variables are not automatically initialized. If we've got a local variable, let's see, this hours worked as a local variable. If we don't assign it, it's going to automatically, when we first create it, if we don't assign it, it's going to be assigned to, nothing. It does, well, I shouldn't even say that. It just doesn't even initialize it. It doesn't have anything. In fact, if you were to dig into it, it probably would have whatever was previous in memory there, if anything. where global variables are automatically initialized to 0 if they're numeric, or null if they're a character. All right, so in the next video, we're going to talk about static local variables. This is gets a little bit more into your global variables and your global constants, but a very distinct variation of that. And we're going to talk about that in the next video. See you then.